All right, so for our third example today, we're going to look at how Excel can help us to deal with some complications in our linear program. And by that I don't mean necessarily bad things, but it's just, if you think about it, the graphical approach that we used before is really easiest if you only have two variables, or can reduce your problem to only two variables, which isn't always the case, right? We might have, instead of just corn and oats to grow, maybe it's corn, oats, and beans and squash or something like that. So in that case, right, graphically we would have to work in some sort of hyperplane, which is much more difficult to do by hand. So that's where Excel really comes in handy, is to work with more than two variables. So on the Word document that I posted, there's a problem about a snack company that's making a mix of different types of nuts. So we've got peanuts, almonds, cashews. And so those are going to be our variables, right? Because they're making this mixture and we have to decide how many pounds of each that we want to put in the mixture. So I'm going to go ahead and do my labels. Peanuts, which is going to be P. Almonds, which I'll call A. Cashews. Let's do C. No surprise there. And as before, I'm going to initialize those all to 0. And just to make it clear, I am defining those variables, verbally at least, to be pounds of peanuts, pounds of almonds, and pounds of cashews. So I'm not going to write that just because it'll make the labels really long, but that's, let's just agree that that's what that is. Okay, and so then the objective for us, well, I'm going to highlight this really quick because you guys know I like that. The objective function is the company wants to make this mixture for the lowest cost possible. And so we were told at the very end that the price of peanuts is $2 per pound, so that's going to be 2p. The price of almonds is $3 per pound, 3a, and then add to that the price of cashews, which is $5 per pound. So that's my objective function. I want to minimize it. And I already had coded those cells to be red, so if you want yours to be red, you can just click on them and then, use this little button here to make it red. So in between these two red cells, I'm going to actually type in that expression in a way that Excel can understand. So I'm going to do 2 times number of pounds of peanuts plus 3 times pounds of almonds plus 5 times pounds of cashews. Okay. So then the constraints that we have, well, we do have some implicit constraints, right? Just as the other two problems, we can't have negative pounds of nuts. So we know that P, A, and C are all going to be greater than or equal to 0. But we're also told that the company can only order so many pounds of each type of nut. Who knows why, but that's just the way the problem is worded. So we can only order up to 10 pounds of peanuts, up to 7 pounds of almonds, and up to 10 pounds of cashews. Maybe that's just the limit for their distributor, who knows. So I am going to be a little sneaky and put the non-negativity constraint as well as that upper bound constraint all in one. And if you are happy with this, you can do it as well, but if you'd rather separate them out as 2 for each variable, that's fine. But the way I'm going to type it in is I'm going to say, okay, I need 0 to be less than or equal to P, which is less than or equal to 10, right? No more than 10 pounds of peanuts. And also 0 is less than or equal to A is less than or equal to 7. 0 is less than or equal to C, which is less than or equal to 10. Alright, so that takes care of our implicit non-negativity constraints, as well as one of the explicit constraints of just how many pounds that they're even able to access, I suppose. Second thing is that we know our customers want no more than 50% of the mixture to be peanuts by weight. So if you think about that, one way to formulate that would be to say that P is less than or equal to A plus C, right? Because if we have A plus C as the rest of the mixture, we can't have any more than that to be peanuts, is the way I think about it. But another way to think about it, I suppose, is you could do something like P is less than or equal to 50% of P plus A plus C, right? Because that would say that you've got no more than half of the total weight. So if you think about rearranging that equation, right, distribute the 0.5 to each one, and then you could subtract the 0.5p to the left. So you'd have 1p minus 0.5p would give you 0.5p on the left, and then 0.5a plus 0.5c. So when you divide out that 0.5 coefficient that they all have, you'd have that p less than or equal to a plus c, which was how I first formulated it. But maybe just to be super clear, we'll write it this way. We also know that our customers want at least 20% cashews. So this one will look similar, only we're going to have C greater than or equal to 0.2 times P plus A plus C. Right, so that one's at least 20% of the total weight. And then the last thing that we know is that the company wants to make a total mixture that is 10 pounds. So that's going to be P plus A plus C equal to 10. And I believe that covers everything. So, right, we have a few more constraints than we've seen before, but that's okay. We can deal with it. Presumably, Excel can deal with it. We'll find out in a minute. So now let's go ahead and code in those values in a way that Excel can understand. So what I'm going to do this time is have this left-hand bound of 0 be in this column for these three constraints, and then put the variables in the middle and then the upper bound so that it kind of looks the way that we've written them here. So for this first, I guess for column B, I'm going to put in the 3 zeros. And then in column C, well, here I want to reference pounds of peanuts, so I'm going to choose A2. In C5, I want pounds of almonds, so I'm going to do B2. And in C6, I want pounds of cashews, so I'm doing C2. And then on the right, I'm going to bound those by the constants that we have. So 10 for peanuts, 7 for almonds, 10 for cashews. Now these three don't have that lower bound thing going on, but I don't want to get confused about where my variables are. So I'm going to start over here now for the expression that is on the left. So here the expression on the left is P. So I'm just going to do equals and then reference A2. And the expression on the right now, usually we have a constant here. This time we don't, right? We have another expression, but that's okay. We can still enter that as an expression, and so, and then just still remember that we want this value to be less than or equal to whatever this value turns out to be. So for that upper bound, I'm going to type equals and then 0.5 times P plus A plus C. Close it off with the parenthesis, hit enter. Same thing over here. This time what's on the right is actually a lower bound, but because of the way we've written it, we'll do still the variables. In this case, always are going to be in column C. So I first want to reference cashews, and then I want that to be greater than or equal to the expression 0.2 times, sorry, I was blocking that, 0.2 times P plus A plus C. Whoops, I actually typed out C. C2 is C this time. Enter. And then for this one, I still want my variable expression on the left to be in this column, so I'm going to type in the P plus A plus C. And then this time I do have a constant value of 10 on the right. So I've switched things up a little bit. Previously I had all of the inequalities written out again to remind myself, but this time, just to keep space sort of efficient, I'll just reference these formulations when I do my constraints. And so that's why it was important to me to sort of maintain the ordering. So, if there's a constant on the left, it's here. All of our variable expressions in the quote middle are here, and then everything on the right is in this column. Okay, so I think that's good. Let's go to Solver. So data, Solver. And so Excel likes to guess the objective function, and right now it's guessing an empty cell, which is sort of silly of that of Excel. So we're going to delete that and then select our objective. Why is that not working? Okay, so I'm going to click this button. There we go. Okay, so our objective now is this one. Hit enter. We're going to minimize it this time. It's a little different. And then we want to change the variable cells A2 through C2. Whoops, oh no. I accidentally ran Solver too early. Okay, so I'm going to cancel that. Go back to Solver. Okay, so right, I've got my variable cells in there. Now I need to add some constraints. Alright, so for the first one, I want to do, let's see, how do I want to do this? I guess I'll go left to right. So I want this to be less than or equal to this one. And then I'm going to add. Remember, I've only done half of that, so now I'm going to do this is less than or equal to this one. And then move on to row 5. So same thing, just go left to right. 0, less than or equal to this thing in the middle, C5. Add. I'm only halfway done, so now I need to start with C5. And that's going to be less than or equal to D5. Moving on to the 6th row. This is the last one with 2. So I'm going to do 0 less than or equal to C6, and then C6 less than or equal to D6. Alright, so the rest should be relatively easy because there's only one per row. So now on to row 7. I want this to be less than or equal to this. Row 8, I've got this is now greater than or equal to this one. And then for the final constraint, we're actually going to use that equality for once. So this cell is going to be equal to this cell. So now I should be done with all of my constraints. So I'm just going to double check them really quick because, I didn't have my reminders in here. So I've got that, let's see, B4 less than or equal to C4. So that's 0 less than or equal to P. That looks good. And then P less than or equal to 10. Is that, oh, okay, they reordered them. Okay, right, so we've got 0 less than or equal to P, 0 less than or equal to A, 0 less than or equal to C, and then we're doing P less than or equal to 10, A less than or equal to 7, C less than or equal to 10. That was a little confusing, but we figured it out. And then let's see, C7 was P less than or equal to that, 50% thing. Cashews is greater than 20% of the total weight, and we know that the sum of P, A, and C has to be equal to 10. Alright, so we're going to keep this little box checked, switch this off to simplex LP, and then hit solve. Remember that this isn't an integer program, right? Because we can have like 1.3 pounds of peanuts, and that's okay. So we don't have to worry about that. We're just going to click solve. Let solver think about it for a minute. It's working so hard with 3 variables. Think about working with like 10. It slows down quite a bit. All right, so we found a solution. That's good. Let's look at it. All right, so this says that our optimal solution is to have 5 pounds of peanuts, 3 pounds of almonds, 2 pounds of cashews. So we've actually like exactly met our percentage constraint, right? 50% peanuts by weight, 20% cashews by weight. That kind of makes sense, right? Because if we want to minimize the price, peanuts are cheapest, cashews are most expensive. And then almonds can kind of do whatever they want, right? So we just filled up the rest with almonds so that we had 10 pounds total. And so that gave us a lowest price of $29 for the 10-pound mixture. So that's not too bad. All right, so that's a good example of using more than 2 variables. Again, you wouldn't want to graph this by hand. It's at least not easy to do so. So using Excel in this case is the way to go. All right, well, I think now you've listened to me ramble on about Excel enough for today. So take a break, and then I guess you guys are going to convene at 1 to work on some of this stuff yourselves. So if you have any problems or anything, email me, and I'll talk to you all soon.